6.4b. For this lesson, we're going to solve polynomials by factoring. Okay. So just some review. We got to be able to factor in order to solve by factoring. So first one, okay, factor 25x to the fourth minus 36. Now remember, whenever we factor, the first thing we always need to do is to check to see if we have a greatest common factor. In this case, we do not. Okay, so after greatest common factor, we move to special cases. And again, the indicator for our special case is two terms. And then we do have that. And we got perfect squares in this case. So we are doing a difference of squares. And I'm squaring 6 to get 36. And I'm squaring 5x squared in order to get 25x to the fourth. Okay, so again, separating into our two binomials. 5x squared will be the first term in each. And then 6, and this is the second term, and then opposite signs. So there's the first one. Second one, looking for that greatest common factor. I'm seeing that there's b's in all of them, and there's actually two b's in every single one, so I'm going to factor out a b squared, which will leave me with b squared times a squared minus 8ab plus 16b squared. Now, I still have squared terms inside the parentheses, so that's probably going to factor further. And it's a trinomial, so we're just going to use some trial and error. I have to do a times a in order to get a squared. And my signs will both have to be negative, due to that being positive and that one being negative. And then ways to multiply and get 16b squared, 4b, or 1 and 16. I'm thinking that 4b is going to work in this case. And then just doing the outside inside to check, we get negative 4ab, which does combine to get our negative 8ab there. All right, so just some review on factoring. Okay, a little bit more. We got no greatest common factor here, but we do have two terms, so that's a good indicator of a special case. And in this case, it is a difference of cubes. Okay, again, x cubed, that's my indicator, that's a perfect cube. X, and then I'm cubing 2 to get 8. And when it's a difference of cubes again, it's a binomial times a trinomial, and I'm just taking those two terms, x and 2, and then we square that term, multiply the two terms to get 2x, and then square the last term to get 4. And again, SOAP, same sign, opposite sign, always positive. It's always the same as the original. Okay. All right, now when we factor with four terms, again, when we have four terms, we are going to factor by grouping. Okay. Now, what you're going to notice in this one, it's a little trickier because there's no common factor between bx squared and 2a. So this one, we actually have to manipulate a little bit. Okay. Because I want to get my a's with my a's, so I'm going to write those. And I'm going to rewrite this whole polynomial, ax squared plus 2a, because I want to group those two terms. And then I'm going to have bx squared plus 2b, because then I can group those two terms. Now, in those two terms, I'm going to factor out an a, so a times x squared plus 2. And out of these ones, b is a common factor, so I'm going to factor out a b. And then again, now it's like I have two separate terms here, here, and here. And the common factor between those two is that x squared plus 2. And then a plus b. So that is that one factor. Right. Then the last one here. Okay, we got a trinomial with no greatest common factor, so no special case either. So I'm just going to use trial and error. So I got to multiply and get x to the fourth. So I'm going to start with x squared and x squared. So you can do x and x cubed, but that's probably not going to work since this middle one is x squared. Okay, my signs, I have a negative and a positive, so I will have to have opposite signs. And then ways to multiply and get 21. 1, 21, 7 and 3. 7 and 3 will combine to get to that 4. Okay, Now I want positive 4, so I'm going to make that 7 positive and the 3 negative. Okay, again, double checking that the middle term is good. We get negative 3x squared and 7x squared, which does combine to get that 4x squared. All right, so that was some review, just being able to factor. And again, in order to solve by factoring, we need to be able to factor. So, first one, when we solve, okay, solve by factoring, we need to factor, obviously. Okay, greatest common factor, I see 4y's and 2y's. Okay, so 2y's are in each. So I'm going to take out that greatest common factor, and it's going to give me 2y squared minus 18 equals 0. Okay, and then at that point, we need to try and factor further. Oh, I did not take out the greatest common factor. Okay, 2 and 18, we can take out a 2. Okay, so we're left with y squared minus 9. Now this one goes further. That is a difference of squares. So we got 2y squared times y plus 3 times y minus 3. Again, we square y, we square 3. All right, now saying that it's equal to 0, that's an indicator that we are solving. And then at this point, we're going to take each of those factors and set it equal to 0. So I got 2y squared equals 0. And solving for that, divide by 2. You get y squared is still equal to 0, square root. And you get y is equal to plus or minus 0. There's no plus or minus 0, it's just 0. And then, since this was a square, this answer right here is representing 2 of them, so that is a double root. So that's 2 of the 4 answers I should get. The degree of the polynomial tells us how many solutions we should have. So there's 2 of them. The next one is that y plus 3 equals to 0, which y is equal to negative 3. There's our third answer. And then finally, y minus 3 equals 0, for y is equal to 3. So my 4 answers are 0, 0, negative 3, and 3. All right, moving to the next one. Okay, factoring. 2 terms, no greatest common factor. 2 terms, so that's a good indicator of a special case. And I see x cubed, so I'm thinking difference a cube since it's subtracting. And I'm cubing 3. So setting it up, we got our binomial times our trinomial, x 3, and we're going to square, multiply, square. And then again for our signs, SOAP, same, opposite, always positive. All right, now that we have it factored, okay, we need to actually solve. And when we do these difference of cubes, that trinomial will never factor, okay? So we need to set each one equal to 0. So I'm going to do x minus 3 is equal to 0. We get x is equal to 3. That is one of our 3 solutions, okay? So and then on this one, again, set it equal to 0. And I said that will not factor further. And we have a quadratic. So we need to solve a quadratic that does not factor. So again, this is where you can go ahead. You can use completing the square. You can use quadratic formula. That is the route I would go for this case. Okay, either one works. So quadratic formula, x is equal to negative b plus or minus the square root of b squared, which would be 9, minus 4ac all over 2a, which is going to equal negative 3 plus or minus the square root of 9 minus 36 over 2. So we get negative 3 plus or minus the square root of negative 27 over 2. Now, we got that negative inside the square root, so we're going to have to bring out an I, and we're going to see if 27 simplifies. 9 times 3, 3 times 3, I got that group. So simplifying that, we get negative 3 plus or minus 3i, because of the negative inside, square root 3 over 2. And then, to have it in standard form, we got to split those terms up. We get x is equal to negative 3 halves plus or minus 3i root 3 over 2. And right there, that right there is counting for 2 of our solutions since we have plus or minus in there. And there we go. We got our 3 solutions. All right. So the next ones, again, whenever you're solving, you're always setting it equal to 0. So we got to bring that 18 over. So we're going to start by doing that. We get x cubed plus 2x squared minus 9x minus 18 is equal to 0. Now, solving by factoring, again, we have 4 terms. The only method we know how to factor 4 terms is by grouping. So in that first group, I have x squared in all of them. So we're going to factor out an x squared. That'll leave me with x plus 2. And the next one, I see negative 9 in all of them. So then we're left with x plus 2. And whenever you are factoring by grouping, these should end up being the same. Okay, because now that's common. So I can factor out that x plus 2, which I'm left with x squared minus 9. Okay, and if you can factor further, okay, at this point there's a couple routes you can go. You can just say x plus 2 is equal to 0, and we get x equals negative 2. Okay, and if you don't want to factor that further, it will be the quicker way, but we can say x squared minus 9 is equal to 0. X squared is equal to 9 square root. You get x is equal to plus or minus 3. Okay, or if you were to factor that further, you're going to get that x plus 2 times x plus 3 times x minus 3. That difference of squares. Setting that, you're still going to get that positive 3 and negative 3. Okay. Either way, you should get to those 3 solutions. And we should also have 3 solutions since it's a cubic function. All right, next one. Okay, we got 16x to the 4th equals 81. Get it set equal to 0. So bringing that 81 over, we're going to get 16x to the 4th minus 81 is equal to 0. Okay, I notice that that is a perfect square. Okay. So what am I squaring to get those 2 terms? I can say 4x and then 4x squared, sorry, and 9. So we're going to end up with 4x plus 9, 4x minus 9. Equals 0. Okay, so at that point, I can factor this one further. Oh, the minus, we don't know how to do a sum of cubes. We know how to do a difference of cubes. So I'm going to be left with that 4x squared plus 9 times 2x plus 3, 2x minus 3. And again, it's set equal to 0, so it's telling us to solve. So we're taking each of those factors and setting it equal to 0. So 4x squared plus 9 is equal to 0. Bringing that over, you're going to end up with 4x squared is equal to negative 9. Dividing by 4, x squared is equal to negative 9 fourths square root. You're going to get x is equal to plus or minus I, and then we got square root 9 over square root 4, which will simplify to plus or minus 3 halves I. Square root 9 is 3, square root 4 is 2, and then we just put that I on the back. Okay, so there is 2 of our solutions since we got plus or minus. We need a total of 4. 2x plus 3 is equal to 0. 2x minus 3 equals 0. So 2x equals negative 3. Or x is equal to negative 3 halves. 2x equals 3. X is equal to 3 halves. So we got 3 halves, negative 3 halves, and then plus or minus 3 halves I. Okay, so big thing is the degree of the function tells us how many solutions we should have. You factor it. Once you factor it, you set those factors equal to 0 and solve from there. All right, so that was solving by factoring. 6.4b. Okay, solve the equations. There are 15 problems. Make sure you do as many as you need in order to understand how to solve. If you have any questions, let me know. Otherwise, have a good day.